Morning, students. So what was the last topic we saw yesterday? Anybody? What was the last topic that we saw yesterday?
Sir,
Yeah, tell me.
we saw the formula mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2.
That is the lens maker's formula, right? I think that is the last concept that we have seen. This one, right? 1 by f is equal
Yes,
to
sir.
mu2 divided by mu1 minus 1 into 1 by r1 minus 1 by r2, where mu2 is what? It is the refractive index of the refracting material. What is mu1? It is the refractive index of outside medium. R1 and R2 are, what are they? They are the radii of curvature of the lens. So we know the fact that radius is singular, radii stands for plural. So radii, because there are two curved surfaces with respect to a lens, generally, right? May not be two curved surfaces, even one can be there. So it is the radius of curvature of those two curved surfaces that we are trying to talk about. Right? So let us do a small problem that is based on that concept. So what does the question say? Example 9.7. It says, a magician during a show makes a glass lens with mu is equal to 1.47. Okay. So glass lens with refractive index 1.47 that disappear in a liquid. Okay, when you place it inside a liquid, it can disappear. What is the refractive index of the liquid? Could the liquid be what? Okay. So here observe, I have to state some important points. Don't look at the solution. I have to say some important points related to the lens maker's formula. Please make a note of all these points. These are very, very important. First, if lens is cut into two equal parts along the principal axis. Okay. If the lens is cut into two equal parts along the principal axis, so if you take the lens to be like this, right, and if this is the principal axis, if you cut it equally into first half and second half like this, then you try to move them, then the first half will look something like this, and the second half will look something like this. Now the question is, what is the focal length of the first half and focal length of the second half? Okay. Remember, if this is taken as the first surface, this is taken as the second surface. If this is R1 and this is R2, now what will happen is, When you break it into two equal parts, still there is the first surface, second surface, first surface, second surface. So the first surface will still have the radius of curvature R1, and the second surface will still have the radius of curvature R2. So when you use the formula 1 by F is equal to mu2 by mu1 minus 1 into 1 by R1 minus 1 by R2, that implies F1 and F2 will be the same, right? And what will it be equal to? It will be equal to F, that is the original focal length. Means what I'm trying to say is, if the original focal length of the source lens is F, and if it is cut into two equal parts at the bottom and the top, then what we can say is, then the focal length of the smaller pieces is still the same as the original lens. That is the meaning. Okay, it is a very, very important point. Please make a note of it. There are many questions that are asked based on this topic. Right? Please make a note. Let me know once you're done. So let me know if you're done.
So I have a doubt in this diagram, sir.
Tell me. Tell me.
So after separation, sir, in the right hand side diagram,
Okay.
which is R1, sir? I didn't understand how R1 is the space between both.
See. No. This. Now, okay.
Yes, sir.
It is still measured from the center.
Even for the blue one also it's the same thing, right?
Yeah. Same. Because they are part of lens only, the same curvature and all those things. See, if you have this kind of a doubt, just draw dotted lines like this and get it confirmed.
Okay, sir.
Okay. See, 1 minute. Just want to make it more precise. Actually, R1 and R2 will be measured from here, from the surface, right? From the surface till the center. This is R1. This will be R2. Now I think you'll be more clear.
Yes, sir.
Okay, so the focal length is still going to be the same.
Completed, sir.
The second point is, lens is cut into two equal parts perpendicular to the principal axis. Then what will happen? See, whatever I'm doing now, don't think it is applicable only for convex lens. Whatever I'm doing is applicable for any kind of a lens. Okay. So if I break it like this, then this will be the first part. This will be the second part. So how is the new lens going to look like? It looks something like this, right? So the radius of curvature of the first part is R1. The radius of curvature of the second part is R2. If the focal length of this length is F. Okay. Now what will happen for the first part? One is R1 only. What about R2? So when you break it like that, what is happening to this side? It is becoming of what nature? It is getting converted to what nature?
Concave, sir.
No doubt. This is the first surface, second surface. I'll call it like this. S1 and S2. Surface 1 and surface 2. Now tell me. It's S2 is planar in nature, right?
Yes, sir. It
So
is.
radius of curvature of S2. So what is the radius of curvature of a straight line?
It'll be the length of the line itself.
Infinite. You can't define the radius of curvature for a straight line because the curvature is like this. Okay, if the curvature is like this, then the radius is R. Okay. So if I increase it more, then it becomes more. If I increase it even more, it will become more. So if I keep increasing like this, there will be one particular point where that bigger circle will appear like a straight line. So the radius of curvature of a straight line becomes infinite.
Okay, sir.
Okay. So that is one thing. And similarly for here, S1 and S2, this is R2 and R1 will be infinite. So let the focal length of the first part be F1, focal length of the second part be F2. 1 by F1, I will call it as mu2 divided by mu1 minus 1 into 1 by R1 minus 1 by R. Okay. 1 by F1 is equal to mu2 is the refractive index of this material. So initially, let's say 1 by F is equal to, let's say the refractive index of this material is mu and the outside medium is 1. So mu2 is mu, mu1 is 1. So mu minus 1. Okay. Let us say R1 is R and R2 is also R. This for an instance, I'm considering that both the sides are of equal radius of curvature. So 1 by F will be equal to mu minus 1 into 1 by R1 is plus R minus 1 by R2 is minus R. Okay. So lens maker's formula is the only formula where you will not apply sign convention during the derivation. You will apply the sign convention only during its application. So this will be equal to mu minus 1 into the whole divided by, into 2 divided by R. Right. So F is equal to R divided by 2 into mu minus 1. Or I can leave it with this step also, not an issue. So this will be equation number 1. So 1 by F is equal to mu minus 1 into 2 by R. Okay, please make a note till this point. Let me know once you're done.
Done, sir.
Okay. Now, what is going to be the focal length of the first part? mu2 is mu1 is 1 minus 1 into 1 by r1. R1 is r. So 1 by r minus 1 divided by infinity. So this will become mu minus 1 into 1 by r. This is 1 by f1. Correct? Similarly, what will be 1 by f2 value? You guys tell me. Everyone tell me.
Be the same thing, but 1 by infinity minus 1 by r.
Correct. So it will be mu minus 1 into 1 divided by r1 is how much? Infinity minus 1 divided by r2. What is r2? Be careful and tell me what is r2. Minus r. 1 by f2 is equal to mu minus 1 into 1 divided by f. Okay. So what will you get? Now what do you think is the relation between f1 and f? F1 is equal to f2. But this is equal to what in terms of f? What is it in terms of f? So shall we divide and see?
Yes, sir. It will be 1:1, right, sir?
1:1. Do you think it will be 1:1?
Yes, sir.
1 by f, that is initial, is mu minus 1 into 2 divided by r, divided by 1 by f1 is mu minus 1 into 1 divided by r. Mu minus 1 will get cancelled, r and r will get cancelled, which implies f1 divided by f is equal to 2. Then f1 is equal to 2. So what will happen? The focal length will get doubled. Okay, that is when you cut it into two equal parts, what will happen? The focal length will get doubled. Okay.
So, sir, this is the ratio between
Next.
original focal length and the new focal length, right, sir?
Yes. So what? Yes, that's right. So what they will do is they will tell you the focal length of the initial convex length that is given as something f. Now it is cut equally into two parts vertically. Now what is going to be the new focal length? Suppose they give the value to this 5. Then what will be the new focal length of the smaller piece? It will be what will happen?
10, sir.
The new, it will become 10. That's it. So that is how the questions will be asked. At that point, you need not sit and do all these things. This is only for you to understand why it has come. I could have directly told you, but you will not understand. No? So, now what will happen if the lens is immersed in a medium of greater refractive index. So when the lens is immersed in a medium of greater refractive index, what is going to happen? That is, if this is mu2 and the outside medium is mu1, okay. So what is the formula? 1 by f is equal to mu2 divided by mu1 minus 1 to 1 by r1 minus 1 by r2. Okay. Now if I take the same thing and put it into some liquid whose refractive index is going to be mu dash, okay, where mu dash is greater than mu2. Here what I'm trying to say is here mu1 is less than mu2. Now if I put it in a medium where the refractive index is greater than the refractive index of the lens itself, then what will happen to the new focal length? 1 by f dash will be equal to mu2 divided by mu dash minus 1 into 1 by r1 minus 1 by r. Okay. Now listen, here mu2 by mu1 is greater than 1. Accepted?
Yes, sir.
Right. So value greater than 1 minus 1, I can say that there is a possibility that this value will be positive, greater than 0. Okay. So I can actually put it like this. 1 by f is directly proportional to mu2 by mu1, mu2 by mu1 minus 1. Okay. Whereas here, 1 by f dash will be equal to what will happen? That is also proportional to mu2 by mu dash minus 1. Right. But what will happen to mu2 by mu dash? mu2 by mu dash will be less than 1. Why? Why will mu2 by mu dash be less than 1? It's very simple. Look at the equation and tell me.
Mu dash is greater than mu2, so it will be greater than.
Yes. So 1 by f dash will become negative. So what I'm trying to say here is, if initially the focal length of the lens is positive, then when it is immersed into a medium of greater refractive index than the lens itself, then its focal length will become negative, means its sign will change. Okay, so sign changing in the case of a lens is a very big deal. That is, when this kind of a thing happens, then convex lens starts behaving like a concave lens and vice versa. Okay, convex lens starts behaving like a concave lens and vice versa.
Done, sir.
Good. So the question that is there, no, the one which is given here, now try to read it. A magician during a show makes a glass lens. The meaning of glass lens is, the lens is made of glass, obviously, with refractive index 1.47. And when it is immersed into a liquid, the lens disappears. What is the refractive index of the liquid? Could the liquid be water? Now you tell me, which case are we trying to talk about?
The third case, sir.
So third case, what will happen is, the lens, initially if it is a concave lens, it will become a convex lens, but it will still appear. Means we will still be able to see that lens. Okay, but what did they say here? They told it disappears. So if it has to disappear, then this has to be immersed into a medium of exactly the same refractive index as that of glass. Okay. When we do that only, what will happen? The focal length will become infinite, means it will become like a water surface itself. See, 1 by f is equal to mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Try to understand this. No? If mu2 is equal to mu1, then what will happen? 1 by f will be 0. Mu2 by mu1 is 1. 1 minus 1 will be 0. Then the focal length will become infinite. Means you can't define the focal length of that kind of a lens itself when it is placed in a medium of the same refractive index. Okay. It is going to disappear. Rohan, are you able to understand what I'm trying to say? So refractive index of the liquid must be equal to 1.47. That is of the same value itself. Okay. Then what will
Will be
happen
1
is
minus 1 is equal to 0, sir.
yeah, that is the reason. 1 by f will be 0. 1 by f will be 0. Then f will become infinite. So focal length of which lens is infinite? You cannot define the focal length of that kind of a material which does not have a radius of curvature at all. And that is nothing but a plane sheet. So what will happen is, though this lens is made of glass, it is a lens, but when you immerse it in a liquid of the same refractive index, it is no more going to be a curved lens, it will become a plane lens. I cannot say plane lens, I'll call it as a plane sheet of glass. And the next question is, could the liquid be water? No, it can't be, because water's refractive index is 1.33. Okay.
So I have a doubt, sir. So the lens disappears in the sense like we won't be able to see it at all, sir.
The lens at all. You won't be able to see the lens.
That means the image found will be virtual, right, sir?
It's image form will be virtual, but here we are not placing anything. This formula, right? Lens maker's formula is there, right? So as far as lens maker's formula is concerned, you will not be concerned about the object distance or image distance. You will only be concerned about the nature of the lens. Because
Yes, sir.
what is it? It mainly speaks about focal length and the refractive indices, right? I told you yesterday itself. See, suppose you go for an eye checkup, right, to a doctor. They say that this is the power of your eyes. Right? In your lower grade, you would have learned this thing. What is 1 by f actually? The reciprocal of focal length has a special name. What is it? Or don't remember? This is what we call it as power of lens. You would have learned something like this diopter, something.
Yes,
No?
sir. Yes, sir.
So 1 by f is nothing but the power of a lens. So indirectly, this lens maker's formula, by calculating the focal length, you are actually indirectly calculating the power that is required for the person. So, for example, every specs will have a specific amount of power, right? Each lens can have a different amount of power. All those values are calculated only by this.
Okay, sir.
You have to understand. So, it depends on what material. Some people want a glass frame. Some people want the lens to be made of glass material. Some people want the glass to be made of fiber. So all these materials have different refractive indices, right? So based on that only, the power of, so based on all these calculations only, they will design that particular lens and give it to the person with the defect.
Okay, sir. Understood.
Yeah. So lens maker's formula mainly speaks about this thing. So to answer your question here, what will happen is, we will not be concerned about whether you will be able to see a virtual image or a real image. When this, let's say it's a convex lens of refractive index 1.47, when I put it into a medium of the same refractive index, you cannot see this lens at all. You cannot see in the sense, you cannot see it literally. Means that lens will disappear, but it is still there. But if you put your hand inside the liquid, and try to take it out, lens will come out. But when you see from outside the beaker, you will feel as if the lens is not there at all.
Understood, sir.
Understood? So moving on to the next concept. Yesterday you asked me, 1 by V minus 1 by U, sir, is it 1 by F? So that's called as lens formula. That is what we are going to see. Okay. So we'll just try to recollect few basics with respect to a lens. I think different types of lens I've told yesterday itself. No? Did I say that? Biconvex,
Yes, sir, you
biconvex.
told, sir.
This is the one. Biconvex, biconcave. All these things are there, right? So you remember the parts of a mirror, right? You have a pole, center of curvature, all those things, aperture, and all those things. In a similar way, lens also has different parts associated with it. Let's see how much you remember. Okay. So there is a center of the lens, which we call it as, any idea of the name of this stuff?
Ortho center, sir.
Ortho center is mathematical. Ortho means perpendicular. Ortho center is point of intersection of altitudes. That is for a triangle. It's called as optical center. Okay. So this is called as optical center or optic center also. Sometimes they refer to it as like that. So radius of curvature, this side, if I call it as R1, and the radius of curvature, I call this side as R2, we can still note the fact that for thin lens. So what do I mean by thin lens? Thin lens is nothing but the one which has lesser thickness. So for thin lens, what we can say is R is still going to be 2F. Okay. So this is, if I call it as F1, this I will call it as F2. Oh, sorry. This point I will call it as center of curvature of 1. This point I will call it as center of curvature of 2. Okay, Oda? Now, in between the center of curvature and the optical center, there will be F1 here. There will be F2 here. Okay. So that if I call this distance, so you're defining the focal length of the lens, right? From that time, you're writing 1 by F is equal to something, right? Now, what do you think are you speaking about? Are you speaking about 1 by F1 or 1 by F2? So which focal length do you think we are speaking about? We are mainly speaking about the focal length F1. Okay. Now listen. So you know what this point is? It is the center of curvature. R1 and R2 stands for the radius of curvature. All these things are known. These are all simple points. Right? F1 and F2 stands for small f1 and small f2 stand for the focal length of the lens. All these things are okay. But the question is, these are all the parts. Okay. So again, to draw the ray diagram, there are certain steps to be followed. Any idea what those steps are? First one. When you take the incident ray parallel to the principal axis, how will it pass?
Through the focus of the other medium.
Yes. So if it is like this, when you take a ray parallel to the principal axis, after refraction will pass through the focus. Let me call it as F1. Okay, will pass through the focus like this. That is reason why this distance is called as the focal length of the lens. focal length of the lens. And this is the optical center. Right. Similarly, if you take an object placed at the focus on the left hand side, if you place the object here, what will happen after refraction? The ray will pass parallel to the principal axis. Correct? It's just the reversibility of light. Right. Then the third one is if you take a ray hitting the optical center, then how will it pass?
It will pass in the same path, sir.
That this it will go undeviated. Correct? So all these things are going to be the parts of the ray diagram. So having this in mind, what we will do is we will try to derive the lens formula. Okay. Let's say the object is placed at F and is placed between F and 2F. 2F is nothing but the radius of radius of curvature. If I take a ray parallel to the principal axis, what will happen? After refraction, it will pass through F1. I hope this point is clear.
Yes, sir.
And if I take a ray through the optical center, it will travel without any deviation. So if I take this point as 2F2, the image is formed beyond the center of curvature. So if I take this as AB and this as A dash, B dash, and if I take this as the optical center, am I clear? And if I take this as the optical center, so from here, if I drop a perpendicular, let me call this as MO. Now, what is this distance to? The distance from the optical center to the point where the object is placed, what can I call it as? Obviously, the object distance. And this will be the focal length. And this will be the image distance. Correct? Now think of it logically. Tell me the triangles which are similar. Tell me the similar set of triangles. So if I take the triangle BAO, it is similar to triangle what? If I take the triangle BAO, it is similar to which other triangle?
MOF, sir.
MOF. You have to see from the other side, no? This is theta, da. Then this theta.
F of B dash, sir.
This one. It should be B dash A dash. So BA divided by B dash A dash will be equal to AO divided by A dash. Correct? Rohan, did you understand or not? So if I take this as theta, this is also theta, vertically opposite angles. And angle A and angle A dash are 90 degrees because 90 degrees obviously. So by which criteria? Angle criteria, these two triangles are similar. This is equation number 1. Similarly, tell me the other set of triangles that you can see similar. If I take this angle as alpha, then this angle will also be alpha. Then I can say triangle MOF is similar to triangle B dash A dash F. Again with the same criteria A, because these two angles are same and this angle is 90, this angle A dash is 90. So what can I say now? MO divided by B dash A dash is equal to OF divided by A dash. Accepted? OF divided by A dash. Correct?
Yes, sir.
But what is MO equal to in terms of length? MO is the same as AB. So can I write BA divided by B dash A dash is equal to OF divided by A dash F? This is equation number 2. So AO divided by A dash O is equal to OF divided by A dash F. So what is AO? Tell me that.
You, sir.
No. What did I say while deriving?
Minus you, sir.
Which implies minus U divided by, what is A dash O?
It's V, sir.
Minus U divided by V is equal to, what is OF?
F, sir.
Actually, I will write it as F1. F1, 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 F1. OF1 will be F, correct. What is A dash F1?
V minus F1.
Correct. V minus F. Because OF1 is smaller. I changed the name of the
Okay,
point.
sir.
So which implies minus UV plus UF is equal to VF. Divide with UVF on both sides. What will you get? Minus UV plus UF is equal to VF divided by UVF. Right. UV will get cancelled. UF will get cancelled. VF will get cancelled, which implies minus 1 by F plus 1 by V is equal to 1 by U. Now, if I rearrange the equation, 1 by U I can bring this side, 1 by F to the other side. So 1 by V minus 1 by U will be equal to 1 by. And what is the name of this formula? This you have already seen.
Lens formula.
Yes. So what is the difference between the previous one and this one? What was the name of the previous formula?
Lens maker's formula.
Yeah. What is the difference between them? Lens
We
maker's
use
formula.
radii in that.
Lens maker's formula speaks about the refractive index of the material and outside medium along with the radius of curvature, radii of curvature. Whereas lens formula gives you the relation between focal length, object distance, and the image distance. Okay. So please make a note of this formula. Please make a note of this derivation. Okay, you're done.
Yes, sir.
So for today, no, one last point. The last point with respect to this is magnification. So how do you define magnification as? Magnification, M is defined like this. It is defined as the ratio of image size to the object size. So M will be equal to H dash divided by H naught. Correct? What is H dash? It will be AB divided by, sorry, A dash B dash divided by AB. But observe, A dash B dash divided by AB will exactly be the reciprocal of this, that is A dash O divided by AO. So this will be exactly equal to A dash O divided by AO. Okay. So what is A dash B dash? H dash, height of the object, divided by AB is how much? H naught. What is A dash O? Look at the diagram and tell me. You'll be having the diagram in your notes, right? What is A dash O? It is
V, sir.
V. And what is AO?
Minus U.
Correct. What is H naught? H naught is positive. What about H dash?
Negative.
Negative. So H dash divided by H naught will give you how much? V divided by O. But what is H dash divided by H naught? It is a magnification. So the magnification of a lens is V by U, whereas the magnification of a mirror is minus V by U. Okay. So as I told you in this whole chapter, except for lens maker's formula, you will apply the sign convention to every other derivation. Okay, so M will be equal to V divided by U. This is the magnification of a lens. Please make a note of it. So let me know once you are done. Okay. So that is all with respect to lens formula. And yeah, so that will be end of today's session as well. Okay, any other doubt?
No doubt.
So just a minute, don't leave. Just a minute, don't leave. Yeah, now you can leave.
Thank you, sir.
Thank you, sir.
Thank you, sir.